Let's say we wish to study the average number of hours per day that somebody's on their phone. So we collect data from 10 people. That should not say 7, that should say 10. So we collect data from 10 people. I've got 10 data points right there. And that's how many hours per day that somebody's on their phone. I want to give the measures of center. So I want to understand the set with a single number. The first measure of center that we have is the average. Right, otherwise known as the mean. And the equation of this is the sum of the data divided by the number of data points that you have. So here, in fact, before we jump into everything, let's just rewrite our data. Let's call it X, so that way these X's make sense. So my data is called X. And if we're rewriting the data, let's go ahead and order it. We've got 0.5, another 0.5, and another 0.5. We have 2 ones, a 1.5, 2.75, 2.75, 2.75. And the 10th person said that they use their phone 4 hours a day. So the average is the sum of all of this. So we have 0.5 plus 0.5 plus all the way down the line until plus 2.75 plus 4. Right? It's the sum of the 10 values that we have. And because we have 10, we divide by 10. If we do this, we get a sum of 17.25, giving us an average of 1.725. And our units is hours, per day. All right, so the average amount of time that somebody's on their phone, at least from our sample, is 1.725 hours per day. You could have gotten the average using a weighted sum as well. So the general equation for a weighted sum is the sum of the frequencies and the data divided by how many data points you have, or rather the sum of the frequencies. So for instance, here we have 3 0.5s. So I can take that data 0.5 and weight it with a 3. I guess if I'll stick to the same order, it's the frequency of 3 times the value of 0.5, right? 3 people said that they use their phone half an hour per day. And I add to that the next data point and its frequency. So we have 2 people that say that they use their phone 1 hour per day. We only have 1 that responded with 1.5 hours. We have 3 that responded with 2.75 hours. And we have 1 that said 4 hours. And the sum of the frequencies here would be the sum of the 3, 2, 1, 3, 1. But that's just going to return 10 again, right? Because we have 10 data points. You see that it's the exact same equation, but it's useful to know in case you have a data set in which a lot of the data repeats. Then you don't have to add up 10 different things. You're really just adding up, like in this case, we're adding up 1, 2, 3, 4, only 5 things. All right, now that we have the average, let's move to the median. So the median is the center data value. So let's go up to our data set. This is why we had to reorder it. I've got 1 there, 1 there, another one, another one, another one, another one, another one, another one, and I'm stuck, right? Because I have 10 data values, I had an even number of data, I really won't have a center. I'll have 2 data points that are trapped in the center. And anytime I'm in this situation, I just need to take the average of those 2 points. So I need to average 1 and 1.5. So my median is the average of 1 and 1.5, which returns 1.25. All right, that's my median. Now for the mode. The mode is the data point that occurs most often in a data set. So let's clear off all of our work so far. And because it's ordered, we should be able to easily identify these. I've got 3 0.5s. I also have 3 2.75s. So it's okay to have two different modes, right? 0.5 and 2.75 both represent the data point, or rather, they represent data points that occur most frequently in this data set. So we have two modes, and otherwise this is a bimodal set. 0.5 and 2.75. Bimodal, bi meaning two. And finally, the fourth measure of center, the mid-range. So exactly as the name suggests, it gives you the, not necessarily a data point, but the number that's directly in the middle of your range. So it's the average of the smallest data value and the largest data value. So our smallest data value was 0.5, our largest was 4. So we have a mid-range, the number that's right in between 0.5 and 4 is 2.25.